In school, I was taught the Big Bang like it was a completely settled fact. The beginning of space, the beginning of time, and the beginning of everything. So I waited until the lesson finished to find my physics teacher and ask her something. I asked her what came before the Big Bang and what is the universe expanding into. One of those questions physics could actually answer, and the other question, 10 years later, is the reason for this whole video. So let's dive in. Now, just a quick confession I have to make before we go any further. That video that we opened on is wrong. And I put it there on purpose because it's basically the picture everybody has in their head, me included, until fairly recently. But the problem with it is that it makes the Big Bang look like an explosion that happened somewhere, like it happened in some dark, empty room with a glowing seed thing sitting in the middle, waiting to go off. But that only works if space already existed, and the bang happened somewhere inside of it. But that's not the way it worked. The Big Bang happened everywhere, all at the same time. Every single point in today's universe, including the exact spot you're sitting in right now, was once part of that hot, densely packed together state. There's simply no direction that we can point a telescope and say it happened over there. It happened right here too, and it happened everywhere. Which actually answers my first question for free. What is the universe expanding into? But the answer to that my physics teacher gave me disappointed me and confused me. The answer is nothing. It was never some sort of bubble with an outside to begin with. Expansion just means the distances between things are growing. A bit like if you drew two dots with a Sharpie on a balloon and blew up that balloon. The distance between the dots just gets larger. Now that analogy has got a little problem. The room. The space that's outside of the balloon. And if you dwell on that, you might end up right back in this loop. What is it expanding into? But we've already answered that. It's nothing. Our brains just aren't built for that kind of nothing. When you walk out of the room that you're in right now, there's more room, more houses, more streets, more planet, and then more solar system. But that's not how the universe works. There simply isn't a bigger room out there to walk or stretch into. Simply put, the grid of the universe itself is stretching. If you ask what's outside the grid, it's a bit like asking what's north of the North Pole. There is no north left to point to. You've run out of a globe, not run into a wall. So what about before the Big Bang? How far back can we actually see? Rewind 13.8 billion years and the universe gets hotter, denser and smaller in every single direction as you go. At 380,000 years in, we hit our first hard evidence. The oldest light there is. The cosmic microwave background, which we talked about in the previous video. Before that moment, the whole universe was a hot, dense fog, too thick for light to travel through. This is genuinely the oldest photograph we will ever take of our observable universe. But we can go further than we can actually see. In the first 20 minutes of our universe, it was basically one incredibly giant fusion reactor, cooking hydrogen atoms into helium atoms. We know that because the evidence is still sitting there. Count up all the atoms in the universe today, and you should get roughly 3 parts hydrogen to 1 part helium, which is exactly what a universe-sized furnace running for about 20 minutes should leave behind. And we can even recreate a slice of it. the conditions at roughly 1/trillionth of a second. And we've built that on Earth. We smashed protons together and watched early universe physics happen in a tunnel outside Geneva at the Large Hadron Collider. But then the ladder just stops. There's a flaw. It sits at 10 to minus 43 seconds, which is so close to zero it's barely even a number anymore. It's just an intangible wall. Physicists call it Planck time. Below that line, you need Einstein's gravity and quantum mechanics both working on the same problem at once. But the problem is, they just don't get along. Every calculation you try just spits out the same answer. Infinity. And infinity is not an answer in physics. Infinity is the sound a theory makes right before it breaks. So here's the honest version of the map. That singularity you were taught about, the infinitely dense point everything supposedly started from, nobody has ever observed it. It's not a thing that we found out in space. It's what the maths does right before it gives up. And historically, when a good theory's maths suddenly spits out infinity, that has never meant reality actually contains an infinity. It means that the theory ran out of road. Everything about the actual moment, the real t equals 0, lives below that floor. And below the floor, nobody has data. Nobody. What people have are theoretical doors. So let's open these doors. 4 serious answers to what came before the Big Bang, each one built by genuinely clever people. And at every door, we're asking this channel's one real question. How would we actually know it's true? But before we go in, we have one more thing left to leave at the entrance. You might be thinking, something has to come before the universe, because matter can't just appear out of nowhere. Matter can't be destroyed, only converted. That's a fair instinct, and it's mostly right. That rule, the conservation of energy, only holds under one condition, that the laws of physics stay the same over time. In an expanding universe, that condition quietly stops applying, and we can actually watch it stop applying. Light travelling across the ever-expanding universe loses energy as its wavelength stretches. The wavelength stretching since the universe around it is stretching too, and it ends up appearing to us as red. That's why some of the most distant galaxies we have seen through telescopes look redder than they should, because the light travelling towards us has been redshifted on the way. But that energy doesn't go anywhere, it's just gone. Dark energy, however, does the opposite. As space grows, there's simply more of it. But nothing's being broken here. The deeper law underneath all of this holds up fine. It's just that the simple version, the universe keeps a fixed stock of stuff so the bang needed a supplier, doesn't survive the theory we have with our universe, which is actually continually expanding. So let's have a look at all the different doors to answering how the universe works. (1983). 2 physicists who you might know the name of, James Hartle and Stephen Hawking. They came up with maybe the strangest answer anyone's ever given to what came before. Their answer is that the question itself doesn't actually make sense. Here's the idea, built from scratch. We currently treat time like a line. and if you draw a line on a piece of paper, you can clearly see the line's beginning and end. So if time has a start, something has to sit just before that start, right? Hartle and Hawking's move was to ask, what if time doesn't behave like a line right at the very beginning? In their maths, as you get closer to the start, time gradually stops acting like time and starts acting just like another direction of space. There's no sharp edge where the universe begins. It just rounds off, smoothly, like the surface of the Earth right at the South Pole. Frame it like this. You go and stand at the South Pole and ask somebody, what is south of here? There isn't really an answer, and not because it's hidden. The question has just simply run out of surface to be about. Every direction from the South Pole is north, and every direction from the North Pole is south. Hawking's claim was that before the Big Bang breaks in the exact same way. Time rounds off into space, the geometry closes on itself, and there's no edge left for a before to sit behind. In his own words, the universe would neither be created nor destroyed. It would just be. So, does it have evidence? Honestly, the real story here is better than the tidy version you usually get from teachers or from Googling it. Because this isn't a settled monument sitting in a textbook yet. It's a live fight happening in physics right now. In 2017, Neil Turok and two collaborators ran that no-boundary maths through a sharper mathematical tool than the original version used, and got the complete opposite result. In their version, a universe that was born this way doesn't come out smooth and calm like ours. It comes out wild, rough, and in uncontrollable fluctuations which doesn't match the calm, ordered early universe that we actually see in the cosmic microwave background. Hawking's side fired back with a more stable version of the calculation, and the argument's still going on in the journals as we speak. That's what it looks like when people try to do calculus on the birth of the universe. And Hartle and Hawking's idea has a cousin of the same family of thinking, but with a very different personality. In 1982, Alexander Vilenkin proposed the universe literally tunneled its way into an existence, a quantum leap straight from a state with no space and no time into a small expanding cosmos. You'll hear this theory called a universe from nothing, but I'd be very careful with the word nothing. Vilenkin's nothing isn't a philosophical nothing, it's a setup with no classical space or time. But the laws of quantum physics were still there, and still running in the background. Where exactly they were sitting, nobody can tell you. These are just two brilliant ideas that time never had before. One where the question dissolves, and one where the universe just leaps into being. Both taken seriously by real physicists. Neither one has evidence an experiment has actually delivered yet. So let's look at something else that you might like instead. Maybe the Big Bang wasn't a beginning at all. Maybe it was a rebound. A previous universe expands, ages, and eventually starts falling back in on itself under its own gravity. Density climbs everywhere at once, not collapsing towards some point in space. It's the exact same picture from before, just running backwards. And at the moment everything's packed as tight as it can get, it bounces. And our Big Bang is just the latest bounce in a chain with no first link. No creation event required, and no awkward starting line. And look, if that idea feels right to you, like the universe finally makes sense, you're in good company. It's an old idea, it's elegant, it gets rid of the hardest question there is by just making our existence eternal. Which is exactly why what happens next matters so much, because back in 1934, before the Big Bang was even a widely accepted theory, a physicist named Richard Tolman found the crack in it. And it's not a small one. Entropy. Disorder. The second law of thermodynamics is about as bulletproof as physics gets. In any closed system, disorder will build up over time, and it never resets on its own. A bouncing universe is about a closed system as you can get. Every cycle, every collapse, every rebound would make a mess. Heat, disorder, and waste. And the bounce carries that mess straight through to the next cycle. Tolman's point was simple. Each cycle comes out bigger and lasts longer than the one before it. The cycles aren't identical repeats, they grow in size each time. Now if I run that backwards, if the cycles grow going forward, they shrink going backward. Follow that chain far enough into the past and it doesn't stretch out forever. It converges. The eternal no beginning bounce turns out to have a beginning anyway. There's a nastier version of the same problem too. If there really were infinitely many cycles before this one, infinite entropy should have already piled up. The universe should be a lukewarm, featureless soup by now. No stars, no galaxies, no you watching this video. But we know that's not true. So that was a beautiful theory running straight into the second law of thermodynamics, but door 2 isn't done. Modern physics has taken 2 serious runs at rebuilding that bounce theory, both fully aware of Tolman sitting right there watching. Attempt 1 doesn't actually go after the entropy problem directly. It goes after something Tolman's whole argument quietly assumed, that every bounce has to crush all the way down through an actual singularity. Loop quantum cosmology says, maybe not. If space itself comes in tiny, indivisible units only measurable at the smallest possible scale, the way matter is made of atoms, then a collapsing universe might never crush down to an infinite point. At extreme density, that grainy structure of space would push back. Gravity flips briefly from pulling to pushing, and the crunch turns into a bounce, no infinity involved. In the maths, it works. So far though, it's really only been shown in very simplified toy model universes. Whether the full theory backs it up is still an open question. If it's right, there might be fingerprints hiding in the polarization of the microwave background, but nobody has found them yet. Attempt 2 goes straight at Tolman's actual complaint. In 2019, 2 physicists, Ijjas and Paul Steinhardt, rebuilt the cyclic universe specifically to dodge the entropy trap. Their trick? Let the universe grow enormously between each cycle, so all that accumulated mess gets diluted and spread so thin that it can't poison the next round. Entropy still goes up overall, but the entropy density doesn't. Tolman's objection dodged. The problem is coming though, because in 2021, a team led by physicist William Kinney tested that exact model against a separate, brutal theorem, one you're going to meet properly by the end of this film. The result was, because the universe grows a little bit bigger every cycle, its average expansion taken over its whole past is still positive, and the same theorem that catches ordinary expanding universes catches this one too. But keep this pattern in your back pocket, because it's about to become the whole point of this film. Behind this door are theories that say yes, something really was here before us, a real history on the other side of our beginning. And, this is the wild part, a couple of these theories claim we might actually be able to detect it. So let's start with the boldest version. Roger Penrose, the man who proved that black holes are basically unavoidable once matter collapses far enough, thinks our universe is just one aeon in an endless sequence of them. The word aeon means an immeasurably or indefinitely long period of time, an age or a major division of geological time spanning a billion years. His ideas called conformal cyclic cosmology, and it hinges on one genuinely haunting fact about the deep future. If you give everything enough time, everything will die. Stars will burn out, galaxies will drift apart and just dissolve, and even black holes, which would be the last thing standing, would slowly leak away into radiation. What's left, eventually, is a universe that's basically just light. And here's Penrose's idea. Light itself doesn't experience time. A photon, the particle of light, has no internal clock, no sense of scale or size. So a universe made of nothing but light forgets how big it actually is. It forgets how old it is. And a cold, empty, unimaginably large universe with no working clocks or rulers left in it becomes mathematically impossible to tell apart from a hot, dense, and unimaginably tiny one. The end of one eon is the Big Bang of the next one. Which means our Big Bang in this picture is the far future of a universe that came before us. And our far future is somebody else's Big Bang, and it repeats on and on and on. So it's all starting to get a little bit crazy now. So is there actually any evidence for it? And this is what earns Penrose a full explanation instead of a 10-second mention. He actually made a prediction. If previous eons existed, its most violent moments, like the final evaporation of its biggest black holes, should punch straight through the crossover and leave scars on our microwave background. Faint rings or warm spots, he called them Hawking points. And in 2018, his team announced they'd found circular anomalies in the cosmic microwave background data, and they said their confidence was high. A message from before the Big Bang, written into the oldest light there is. But unfortunately, it didn't hold up. In 2020, an independent team reran the search and found the apparent signal basically dissolves once you account for how many random patterns you'd expect to find by chance in a sky that big. Ordinary, boring random skies turned up similar Hawking points. Then in 2024, another independent group went further, building their own machine learning search and running it across both major cosmic microwave background datasets. Their finding was this: once you strip out the known artifacts, there's no statistically significant signal left. and I want you to actually think about what you just heard. A Nobel laureate made a real disprovable claim about the universe before ours. Independent teams went and checked. The fingerprints weren't there. Penrose, who is in his 90s now, is still refining his theory. There's a new version of the mechanism from as recently as 2025. The idea is still alive, but the evidence right now isn't. But we've got one more theory behind it, and this is genuinely my favourite kind. The kind that bets on everything being provably wrong. In 2018, Latham Boyle and Neil Turok, yes, the same Turok from earlier, proposed that the Big Bang isn't an endpoint at all. It's a mirror. There's a deep symmetry in physics called CPT. Flip every charge, mirror every direction in space, run time backwards, and the laws of physics come out looking exactly the same. Our universe on its own doesn't respect that symmetry. Matter beats out antimatter, and time only runs one way for us. Boyle and Turok's idea is that the universe as a whole still respects it. On the far side of the Big Bang, there's a matching anti-universe, made of antimatter, running backwards relative to us. Not a universe that came before ours in a normal sense, the two of them are born together, at the same instant, running in opposite directions. From over there, they would say that we are the ones running backwards. It doesn't need inflation, no new fields bolted on, and purely from that symmetry, it actually spits out testable predictions. It predicts dark matter is a specific particle, a right-handed neutrino with a specific calculated mass, big enough a number, I'm putting it straight on screen. It predicts our ordinary neutrinos have a property that experiments are hunting for right now, in a process called neutrinoless double beta decay. And it predicts, cleanly, that there should be basically no primordial gravitational waves left over from the beginning. The last prediction is a loaded gun, pointed straight at its own head. There are telescopes at the South Pole hunting for primordial gravitational waves right now. It's one of the most wanted signals in cosmology. Find them, and the idea of inflation goes way up. And this theory dies in public by its own stated rules. None of it's confirmed yet though, on any front. It stays tagged as a hypothesis. If you've watched my previous video, you know all about this already. Inflation. The leading theory for our universe is very first instant. Space itself, for a fraction of a second, doubles in size at a rate that's almost stupid to write down. It predicted subtle, statistical patterns in the microwave background radiation before we even had the tools to measure them. And when we did finally measure them, they matched up almost identically. But inflation drags a famous stowaway along with it. In most versions of the maths, inflation never actually stops everywhere. It ends in patches, and each ending is its own Big Bang, a bubble of calm, ordinary space like ours, while the space in between these bubbles just keeps on inflating forever, spawning more bubbles endlessly. Eternal inflation giving you the multiverse. And in that picture, the whole question of this film changes shape. What came before our Big Bang? More universe, older universe, an ocean of inflating space with our cosmos as one bubble among God knows how many others, and still no guarantee the ocean itself ever started. We made a whole film about why serious physicists actually take this seriously, and the evidence at the centre of it is worth 30 seconds twice. Right, you've heard everything. Let's score the whole thing. Every single theory has a caveat somewhere. If you say time never began, the maths underneath that idea is still fighting itself in the journals. You say the universe bounces, and thermodynamics turns your infinite past into a beginning anyway, or the geometry does the job instead. You could say an older universe left fingerprints, but nobody's independently found them. Or you can say we're one bubble in an eternal sea of universes, but that exact sea can't even tell you the odds of its own weather. And standing behind all of it is one theorem, the closest thing this question has to a referee. In 2003, Arvind Borde, Alan Guth, and Alexander Vilenkin proved that any universe that's been expanding, on average, cannot stretch back forever into the past. Somewhere back there, the description just runs out. You'll hear this theorem quoted a lot, in pop science, in philosophy debates, sometimes from a pulpit, as proof that the universe had a beginning, full stop. Listen carefully to what it actually says though. It says classical space-time, Einstein's smooth version of the universe, can't stretch back forever if it's been expanding. It says nothing about what quantum gravity does once you're past that point, because the whole theorem only ever assumed a smooth classical space-time to begin with. It doesn't even lean on Einstein's field equations, just the geometry of paths through that space-time, which is exactly why it manages to catch so many different models. And here's the bit that matters for everything you've just watched. It permits a contracting past, but only on average, not phase by phase. Do you remember Door 2's second attempt? Ijjas and Steinhardt built a contradicting phase into every single cycle. And the theorem caught them anyway, because their universe still grew on net, cycle over cycle. The loophole's narrow. Your entire past has to average out standing still or shrinking. One contracting phase inside an otherwise growing history doesn't count. So here's everything we actually know. We know, and we have observed, the universe was hot, dense, and expanding 13.8 billion years ago. And we've got evidence of that all the way back to its first 20 minutes. What we have as a strong theory is below 10 to the minus 43 seconds, every theory we own stops working. That wall is real. But everything anyone has ever told you about what happened before it is a hypothesis. When I was in school, I was taught the Big Bang was the beginning of everything. Nobody actually knows that. What we know is that it's the beginning of everything we can see. Page 1 of the only book we've ever been handed. The most honest sentence in all of cosmology is carved right into that wall. Here, we do not yet know. That's the honest answer, the professional one. It's the one every door in this film actually earned, and it's the one I'll defend to any physicist who watches this. But you've sat with me for this whole thing now, so here's the unprofessional one. I have been chewing on this exact question for 10 years now, ever since that day in school. Now, for full disclosure, I'm not an astrophysicist. This is just my best guess, and take it exactly as that, only a guess that took about 10 years. Our brains evolved to understand cause and effect. We only understand beginnings and ends. Something made from something else. We live, we die, and the events run one way, past to future. So of course it feels natural to ask, what caused the Big Bang? Or what came before it? That question is basically hardwired into us. But here's my guess. Asking what came before the Big Bang might be something like a syntax error in a universe that runs on strict code. In the actual maths of reality, space and time aren't a stage things happen on. They're one combined thing called space-time. So the Big Bang wasn't matter expanding into an empty room, it was the room itself switching on. Literally the beginning of time as far as this universe's clock is concerned. If time itself switched on at t equals 0, then there's no t before that. Not even t equals -0, like a negative version of 0. It's not an empty void waiting for the universe to start. It's an unallocated memory address. And if time itself is an internal variable, something that only switched on at the Big Bang, then before can't mean chronological past. It has to mean something else. Think about a piece of software or a game, right? The hardware and the source code have to exist before the program runs. Causality needs time to work, but if time is strictly a property of this universe, then there is no before. The Big Bang wasn't triggered by anything. It was the threshold where static, timeless logic decompiled into moving geometry. The universe didn't get caused, it was decompiled like unzipping a file. Here's the bit that convinced me it's more than just a fun idea though. If you knock on a wooden table or on a door or stub your toe against a table, it feels solid. But modern physics will tell you that solidity is basically hallucination, built by your own biology. Because maths doesn't need to magically transform into tiny hard spheres to make a universe, tiny hard spheres were never real to begin with. So if you're just data interacting with other data, why does a wall feel hard? How does maths hurt if you were to stub your toe? Think about a video game. When you run your character into a brick wall, it just stops. Neither the wall or the character are real. That solidity is one line of code. If character position matches wall position, character velocity goes to 0. The maths simply won't allow them to overlap. In our universe, that exact rule has a name. The Pauli exclusion principle, backed up by electromagnetic repulsion. When the atoms in your toe get close enough to the atoms in the wall, the rules governing their electron fields strictly forbid them from occupying the same space, and the electromagnetic fields push back hard. Your brain's operating system reads that mathematical repulsion and fires a signal up your nervous system, and translates that data restriction into two feelings you know very well: solidity and pain. So my best guess, after 10 years of thinking about it, is we don't need a magic spark. We don't need a timeline running before this one, and the universe was never built out of physical stuff, because it was built entirely out of mathematical rules. For example, the speed of light. The Big Bang was just the moment those rules were executed or switched on. We're not living in a physical universe that somebody decided to switch on, but we're living inside the maths of it itself. And that's my answer. By no means am I an astrophysicist or even a physicist. It's not a door, and I'm not asking you to believe it or believe me, but it is my theory, and after 10 years, I'm glad to be finally saying it out loud. So thank you very, very much for watching this video. It's taken a long time to put together. So, thank you if you've got here.